Okay, so question that we were finishing up with yesterday. Right, could one of you remind me what the situation was?
Hit and miss.
Hit and miss. An archer.
Fires 3 arrows.
Fires 3 arrows. And what was the deal with the probabilities?
It's 1 out of 8.
If he hits it once on the first try, it's 1 out of 8. And if he hits it on the second try, it's 1 out of 3.
Well, it wasn't just first and second, was it? It was like if he has hit it, his next shot.
If he hits the target, the next shot increases to
Team made by
1/3.
I know. Right, so we went through, and with the tree diagram, now not only did the probability of him hitting it improve, but obviously the probability of him missing is decreased, so we had to take that into consideration. Alright, so I wanted to know again the probability of him hitting twice, wasn't it? Okay, so we went through and we've got our 3 routes again, the same as we had before. Right? But this time, what kind of probability is this now? What's it called? Conditional. Right? So, because it changes depending on what's happened before. Right? So we came up with these values. All right. Right, we came up with these values. So we had hit, then a miss was 1/8 times 1/3 times 2/3. Hit, miss, hit. So you can see if he hits the first time, the second hit is more likely to happen. The missing is less likely to happen, and so on. So we've got our 3 options. Okay, so we end up with 1/8 times 1/3 times 2/3 is
1 over 36.
1 over 36. You sure?
Isn't it?
How you go back a half? Unless you
Right, so because you've just done it straight on your calculator, it gives you the simplified fraction, doesn't it? So if we don't simplify, we've got 8 times 3 times 3 is 72
And 2.
and 2. This one is 2 over
190.
190.
my calculator.
And this is 7 over 192, is it? And then 192. Okay. Now, how do we find a common denominator? Because we can't add them together without a common denominator. Because what we've got to do is now do 2 over 72 plus 2 out of 192 plus 7 out of 192. So how would you... I mean, obviously, if you've got use of your calculator, you just put it into your calculator. Which, to be honest, with numbers like this, you are going to be able to. Right, so if you put that into your calculator, what answer are you going to get?
I got 43.
43 over 576. Sorry, I had to see you thunder. I was really into it.
43 out of 576?
Yeah. Let's do it to me. PS Julian, that was an thing. What? That was recorded.
Right. She was apologising, that's fine. Okay, so the probability of hitting twice. Now, just one thing to maybe add, I thought, well, I didn't mention it yesterday, I should do. This was about the probability of hitting exactly twice. Now, I didn't use the word exactly yesterday, but I just said what's the probability of hitting twice, but quite often they'll put the word exactly in just to clarify that it is twice and not twice or more or that kind of thing. So, because we could say, what's the probability of hitting twice? Well, I hit twice, and then if I hit a third time, I still hit twice. So we kind of clarify with hitting it exactly 2 times. Would I change anything? So just to remind you, back up here, we had the probability of at least once, we worked out the probabilities of everything, or we did the probability of hitting no times and subtracted it from 1. Will that change for this problem? So if I did the probability of missing all 3 times with conditional probability, the condition that I put in, would that change anything for this problem?
That was a good question.
Hitting at least once. So what we're looking for is the probability, so 1 minus the probability of not hitting at all, probability of hitting 0 times. So what is the probability of hitting 0 times? Is it the same as before or different?
It's miss, miss, miss.
It's miss, miss, miss.
So then it's...
Is it going to be any different from what we did last time?
No.
No, they don't change. Right? Because obviously the condition only played its part if I hit. So if I've missed all 3 times, nothing changes. Yeah, doesn't change at all.
That's me.
Now I could change it further. I could make it even more complicated by saying, well, if I hit, then my next chance is improved hitting. But if I miss, it gets worse the next time. So I could change it doubly, where if I miss, it's more likely I'll miss the second time, maybe my confidence is shot or whatever. Okay, right. So we're using our tree diagrams, we found this, so this probability would still be exactly the same as it was before. Right. Okay, I want to introduce you to just one final thing, because in the Edexcel questions they don't use fractions quite as much. They use decimals instead. Okay, it's exactly the same thing there. All right. Now, there are quite often problems with spinners.
Oh no.
Okay, do you know what I mean by a spinner?
Like a twister spinner.
Yeah.
Like a jack.
Yeah, I did that.
Or like the Hanukkah things that you
On
see.
top.
Oh yeah.
Yeah,
People speak.
No, it don't.
This is how you know she has a lead.
They should have pages.
That's the,
Right. So, for instance, with a spinner, I may have numbers, or I might have colours, or anything, you know, whatever they decide to do. Okay, so what if I had this spinner, and I would say it's a fair spinner, which means every side, you know, it lands on a flat side, yeah? Every side has equal opportunity of landing, okay? So, for instance, if I asked you, say, what is the probability of it landing on red?
2 out of 6, which is 1 in 3.
2 out of 6, that's fine. What would be the probability of it landing on green or red?
Green or red is 3 out of 6.
Alright. I'm also going to introduce my die. Right. Just, I'm still working in fractions at the moment. We'll move on to the decimals in a bit. If I were to spin the spinner and roll the die, what would be the probability of getting red and square number.
Red and square number.
So whatever method you want to use now, you use it. So you could do a sample space, you could do a tree diagram, or you could just use your knowledge of the fractions of things. Up to you. Right. So again, fair spinner, fair die. There's no multiplying or anything. It's actually quite a simple case now.
And there's what? 1, 2.
Okay, let's have a look. I'm going to change this problem in a minute. So there are lots of ways to do it. I want the probability of red and square. Now, let me just check something. So the probability of red and, what do I replace and with?
Times.
Times. And the probability of square, a square number on the dice. Okay, let's just check this. Does this work? So what's the probability of getting a red colour on the spin? Sorry, probability of red. Don't know why I'm rewriting that. It's not rewriting. So I've got 2 out of 6 multiplied by the probability of getting a square number.
2 out of 6.
2 out of 6. So I end up with a probability of
2 out of 6.
4 out of 36.
I feel dumb for red.
I got that to me. Look.
So cool. I just forgot that.
So
That was it.
you were asking how to do it in your head. I would say this is maybe the quicker way. So knowing that if I've got and, we multiply the probabilities. Okay. Now, what's different in this case? Stop misbehaving. What's different in this case is that if it was 2 dice, we'd have to consider both ways round, wouldn't we? Because we don't know which dice comes first. But in this case, I can just say, well, I do the spinner followed by the dice, or I do the dice followed by the spinner. There's not 2 options, is there? I get a red on the spinner, I get the numbers on the dice. I don't need to swap them around. But with the dice, you don't know which way, so you have to think about that. All right? Does that make sense then? Right, let's change this. All right, so a bit of vocabulary. I'm going to say bias is introduced
Oh no, not bias. He's me.
into the spinner and the die. The new probabilities are, okay, so on the spinner I've got, well, what do we have? Red, what colours did I have? Blue, green, white. Okay. And the probabilities, okay, so the probabilities will be at 0.6, 0.2, 0.08.
I don't like this.
Okay.
Do you just convert it into a fraction?
The die, well, that's not a bit. The die, so is 1, 2, 3, 4, 5, 6. Okay, this time we've got 0.2, 0.3, 0.1, 0.05, okay, 0.25. First thing that I would ask you is,
Why isn't there a
what are the missing probabilities?
5 and 6.
white
and
and
five?
So what's the missing probability for white? And how do we find it?
You add up to 1.
Okay, so it should add up to 1. So if I add those probabilities, it should equal 1.
It don't.
0.12 is like.
So I've got 0.6, 0.2, that's 0.8. So this is 0.88. So actually white will be 0.12. Because I do 1 minus the 0.88. 0.12. Make sense?
Yep.
So simple as that. Decimals, fractions, it still just has to add up to 1. Alright? And what about the die? Same thing. Add those together. They have to equal 1. So 0.2, 0.3, 0.5, 0.6, 0.85, 0.9. So I've got 1 minus 0.9 equals 0.1. Okay. So when I introduce bias, it makes it a bit easier for me to do a problem with decimals like this, because when it's fair and I've got 6-sided, to turn all my over 6s into decimals, I might have recurring decimals and things. So I don't really want that. So these, by saying, I introduced bias into the system. Now, do you know what bias means?
No,
Favored.
not in this case. Unfair.
Yeah, it's just unfair. Right? Bias means unfair. And you can see that this die, they should all be equal, shouldn't they? Right, if it was a fair die, it should all be equal. But they're not. So which number is favoured the most?
6. The best one.
Red.
No, 2.
2.
Oh.
Which number? Which number is favoured? Number 2. Now, what should really happen if it's done, like if you weighted a dice, the number that is favoured, the opposite side then has the lowest probability. So what's on the opposite side to 2? 5. Okay? And the opposite side to 6 is 1. So I haven't done mine particularly well. Right, can I ask you then? We do the same problem. What would be again the probability of getting red and square number this time?
This time? I didn't even know this.
So in this case, it's a bit more difficult, isn't it? Maybe than, because you can't do your sample space diagram now,
Can? Are you sure?
because the sample space just.
Could you do a leaf form? A tree?
We could do a tree diagram.
Anything's possible.
I like your. This is
But don't forget what we said. The probability of red and square, we've got the probability of red multiplied by the probability of square number. So what do we get? Probability of red is 0.6 times.
What's the square number?
So square numbers are 1
And 4.
and 4. So the probability of getting a square number is
0.25.
0.25, because we add those two together, right? And so we can work out the probability of 0.6 times 0.25, and we get the answer.
Which I'll tell you in a second. 0.15.
Yeah, you're a little.
Okay. Right. So just to follow on from what we've been doing before then, so I'm going to say I do
Wait, what was the point of saying 2?
what was the point in saying what?
2 is the common one or whatever. What did you just say?
Oh, it's just a point of interest. It had nothing to do with this problem. It's just I was saying if I did actually introduce bias to a die, if 6 is more likely, then 1 is the least likely. Should be. Right. So if I said I do 300 trials, how many times would I expect to get red and prime?
2, 3, 5.
Okay. So over to you. Finish it off then. Finish this question before I give you some past papers. So how many? I do 300 trials using the same spinner and die. Okay. So using this information we've got up here. So I do 300 spins and roll the dice. So that counts as one. Spin, throw the dice, record what happens. Do that 300 times. How many times would I expect to get red and a prime number?
I got my
Okay.
answer.
So red is, we're doing investment.
So we're looking for the probability of red times the probability of prime. So the probability of red again was 0.6. What was the probability of a prime this time? Now prime, what are the prime numbers?
3 plus 0.1 plus 0.9.
So 2, 0.3, 0.1, 0.1. So it's
Not so sure.
0.5. So probability of getting prime is 0.5.
And then you get the
So it's 0.3.
3. So that's for one trial. So now you have to
Well, that's my probability, isn't it?
So she did.
Okay. So the probability of red and prime is 0.3. What do I then do with that?
multiply by 300. You all were like, got it.
So I expect 0.3 out of the 300 trials to be what I'm looking for. So what's 0.3? 90. So I expect 90 times to get red and a prime number. Okay?
Yep.
I think what's best thing I'm going to do now, because we've been through quite a few things, I'm going to give you the pack of past paper questions I've got on probability. The answers are at the back of it, but try your best and then try and find out anything we've not talked about necessarily.
Look how colorful these last few